Okay, so we are revisiting derivatives of inverse trig. What are you doing? Would you like to write on the podium?
No.
Okay. We are revisiting derivatives of inverse trig functions. We're just doing it a different way. So this way is one that I learned after I taught calculus for the first time, and you don't have to teach it this way. I think it makes it easier to remember. And actually, after we do this, I'd be curious if you guys think that I should teach it the way I taught it to you, or if I should teach it this way next year. So you're going to have to give me your opinion. All right, so here's like a proof of it. And then we'll use that idea to do more of them. Leon, are you videotaping this?
Yeah,
Leon, I'm also videotaping this. I was like, what is he doing? He's just like holding his phone. Real serious. Like, can somebody get Leon some paper? Can we share back there? There's also probably paper on the top thing, maybe?
I looked yesterday.
You guys were like, Ms. Rice, we'll learn, but you have to provide the paper. We are fresh out. All right. All right, so here's the proof. We're going to start with y equals sine inverse of x, and our goal is to take the derivative, okay? So if you guys recall, normally we would grab like our yellow sheet and use the little formula, right? We had like different shortcuts for like tan inverse and sine inverse and cos inverse. They each had their own and they were each kind of funky. Most of them had square roots in them. Sometimes it was just a square root. Sometimes it was something on the top and then a square root on the bottom. And then there was a chain rule and it was always like really weird. You guys remember that? Okay, so here's the alternate way to do it. In this way, what we're gonna do is we're gonna get rid of the inverse part. So to undo sine inverse, I have to do sine on each side. So I'm going to say sine y equals x. And then what I do from here is I actually draw a triangle. Okay, so I'm going to draw a right triangle. I'm going to remember SOHCAHTOA. So it says sine of angle y. So here's my angle y equals x. And so that means that x is opposite over hypotenuse. So that means my opposite side is x and my hypotenuse must be 1. All right, now if we use the Pythagorean theorem, we're going to say that whatever this side is, I'll call it a. We're going to say a squared plus x squared equals 1 squared. And if I want to solve for the missing side, then that would be a squared equals 1 squared minus x squared. And then I would square root that, right? And I'm not going to do plus or minus because I know that's a positive side length. So I'm just going to use the positive. Okay. So what we've done now is we've drawn a right triangle. We've labeled the sides to represent this situation. Okay. Now what I'm going to do is I'm going to take the derivative of each side. So what is the derivative of sine? Cos. And then what's the derivative of y? dy dx, right? Or you could say y prime, it doesn't matter. And then what's the derivative on the right side? 1. Okay, so dy dx is the notation for derivative. So we're trying to isolate that because if we can isolate this, then we'll have found the derivative. So I'm going to say dy dx equals, do you want to use the podium? You can stand and write. It's like wheeling. You can put the stuff down right here, whatever stuff is on there. There's probably, is there anything in there? You good? Okay. Yeah. Yeah, one of the wheels locks, but the other one doesn't. It's kind of wheelie. They sometimes come undone a little bit, so then it's like off kilter. Anyway, but it's not. Isn't that nice? Just don't let it. If you fall asleep, it's gonna like wheel away from you. Hey, did you want to do the optional quiz?
Oh no, I was coming to get fingerprints.
I'm sorry. We're Not everyone did races, I don't think. Or maybe they all did, I'm not sure.
Some people did.
Okay. So if we get the dy dx alone, what do we have? 1 over cos, right? You would divide the cos over. Okay, so now we know that this is the derivative, and now we look at our triangle and we figure out what cos y would have been. So cos is adjacent over hypotenuse, right? Is adjacent over hypotenuse, and if I think about that for this triangle, then what would it be? Okay, so I'm going to take this, and I'm going to plug it right in there. So the derivative is 1 over the square root of 1 minus x squared. Now that process is longer than the process we did. However, you don't need a yellow sheet. So that's kind of the benefit, is that later if you're rusty, you might remember the process. You like this way? Okay, so now we're going to do some actual, that was like the proof, now we're going to do some actual practice problems. Okay? I thought I heard it too. You waited too long, now they're gone. All right, here is our first example. Now, there's a proof like that for all of them, but I don't think we need to like keep doing it because it all has this like the same idea. So the first proof we'll do, or sorry, the first example we'll do is sine inverse of 2x. So the process for all of these is the same. So what should we do first? Multiply by sine, or do sine of y equals 2x. And then we could take the derivative. So the derivative of sine is cos y dy dx equals 2. And then dy dx equals 2 over cos y. Okay, now to get the rest of the answer, we have to draw our right triangle and label all the sides. So we have angle y, and then we have opposite over hypotenuse, opposite over hypotenuse would be 2x over 1. So a squared plus 2x squared equals 1 squared. It'd be 1 minus the wheel came off? The whole wheel came off? Oh, it just needs to be screwed back in. That's funny.
Wait, did you say opposite over
Yeah. So, OH?
Oh, wait, sine?
Yeah. So we're doing sine first. We have to do the triangles based off this. So we use this information to make our triangle, and then once we've made the triangle, then we can take the triangle and use it to find this. Mm-hmm. So a squared is 1 minus 4x squared. Coming in with the assist. Can I help him out there? No. That's support. In case you guys are wondering, I put that together all by myself. Just one person. It doesn't matter, I still did it by myself. Are you sure you're not just doing lefty-loosey repeatedly? All right, so we have the third side is the square root of 1 minus 4x squared. And then how do we get this information to come over here? Yeah, so this side, this would be adjacent over hypotenuse, right? That's cos is adjacent over hypotenuse. Since the hypotenuse is 1, we could just take this and plug it in. So we would say dy dx equals 2 over square root 1 minus 4x squared. And I think the cool thing is it like does the chain rule for you, which is kind of neat. Okay, let's try. We'll do tan inverse of the square root of x. Okay, so what do we do first? Yeah, tan both sides. So tan y equals the square root of x. Do you guys like drawing your triangle now, or do you like waiting till the end?
Waiting. Because I get confused.
Now, because it gets confusing. Okay, so this is going to be my triangle information. So what sides did your mom text her?
My phone said so. I had to tell my mom.
Ellen's just getting text messages from other moms. That's funny. That sounds like something my mom would do. I had to explain to my mom like that it's socially awkward for her to start to comment on everything my friends say on Facebook. Like if two of my friends are having a conversation or something, or like my mom would chime in on everything. And I tried to sit down and say she's like, yeah, but I can see it, so I should be able to comment on it. I'm like, yeah, but there's like a social undertone of that being like weird. And I wasn't trying to be mean. I was just like trying to explain it like, don't, like, you're the weird mom, don't be the weird mom, you know? But like I was explaining it nice, and I totally made my mom cry. It was the saddest thing. All right, so what sides are we labeling here? Opposite, right? Not the hypotenuse this time. It's the base side because tan is opposite over adjacent. We're doing a different one this time. Yeah, erase all that. All right, so the hypotenuse this time, we're going to say h squared is 1 squared plus square root x squared. And so the hypotenuse is the square root of 1 plus x. Hi.
Hi, yes. Can I have Emily Stillboy out for Emily?
No.
Dismissal, please?
Yeah.
Thank you.
No.
I have to work.
Shame. It's terrible. But aren't you enjoying this? Isn't this the most fun you've had today?
Like, it's actually like yesterday and today. It's fine doing the notes, and then I get to the practice. I'm like, oh god.
So maybe you didn't like the squeeze theorem as much as you thought. Maybe this will be better, though. All right, so we have this stuff. What do we do now? Now we do the derivatives, right? So the derivative of tan is secant squared. So we have secant squared y times the derivative of y. And then the derivative of square root of x, that's x to the 1/2. Right? So the derivative of x to the 1/2 is, oh, you simplified that and everything. I'm gonna write this the stupid way first. I was like, that was not what I expected to be said, and I was like, that's wrong, and I was like, no, that's right. That's like really right. So we have dy dx. And then Smarty McFarty over there told us that's 1 over 2 square root x. And then what part of this fraction would the secant squared go? On the bottom. Okay, so cos is adjacent over hypotenuse. So secant is hypotenuse over adjacent. Okay, so that means that secant is square root 1 plus x over 1. Okay. So if we write this out, we have 1 on top, and then on the bottom we have 2 times the square root of x, and then we're multiplying that by secant squared. And so our derivative would be 1 over 2 square root x times 1 plus x. I just think these are kind of cool. Anytime you start to see how like geometry and algebra work together, like trig specifically, trig stuff always blows my mind. I really love this stuff. If we could have a class here that was just on trig, I would totally teach that. Nobody would take it, but I would teach it.
Great elective.
It'd be like me and one person. No, Ricky would take it. Me and Nancy and Ricky. I bet I could talk him into it. Yeah, Nancy won't be there because she's graduating this year. But Ricky would take it. He takes the math. He takes the math. Hi, Ricky. Hope you're watching this. All right, here's the next example. Yeah, because I want to show you guys one that has an E in it. This one is going to be y equals secant inverse. I've noticed that a lot of the problems are sine, tan, or secant. And I think that's because those are the ones that are commonly taken derivatives of, if you think about it. I guess cos could be one, but I don't have an example for that. But cotangent and cosecant, you don't see as many of those problems because we don't often take those derivatives. Somebody's hating on those. All right. So secant inverse of e to the 2x. All right. What do we do first? So secant each side. It says seci. No?
There's that test or quiz you gave, and every time you put secant, it autocorrected to sex.
Not every time. It happened once.
I think twice.
And it wasn't autocorrect. It was definitely, I just typed sex. Because I was typing it into the equation editor, and that doesn't have, like, spell check. So that means that's literally what I typed. Yeah. Yeah, the funny thing is, whenever I try to type secant, I type sex usually. Like, that's like a regular thing that I type on accident. So, thankfully, secant doesn't show up that often, you know, but I always have to, like, go back and fix it. All right, so we have, here's our angle y, and then secant, what sides am I labeling? Not the opposite. Hypotenuse over adjacent. So hypotenuse over adjacent. Okay, so we have hypotenuse squared equals 1 squared plus a squared. If I have e to the 2x raised to the second power, what do I have? U4x. I think on assignment at one point I had e to the x squared, and a lot of people wrote, instead of writing e to the 2x, because you multiply your exponents together, a lot of people wrote e to the x squared. And I was like, no! Dang it. All right, and then to get the a alone, we're going to go ahead and subtract the 1. So for this side, square root of e to the 4x minus 1. Okay, so what is the derivative of secant y?
Y times
Yep, secant y tan y
It's like the one
times dy dx. Yeah, that one shows up a lot. And then the derivative of e to the 2x. Wait, what was it? 2e to the 2x?
Yeah.
Didn't you say an x in there? Yeah. Not an x, just a 2. Yeah. I think you had an x wrong. It's okay. All right, so we have dy dx equals 2e to the 2x over secant y tan y and so that's dy dx equals 2e to the 2x over secant y is secant y e to the 2x. And then tan is opposite over adjacent, right? So that's the square root. And then on this one, we can simplify a little bit. What do we think? We like this way? It's a little bit more time consuming, but I think later on it's more memorable. Yeah. Well, because like the nice thing about this is this would work for any of the inverse trig functions and you could do them without knowing the formulas versus the formulas you have to know them. So I think it does add more time, but I think big picture perspective it's easier like later on. Yeah. So teach it this way next time. Teach it the other way. Give them the yellow sheet that has there and explain kind of how it works, and then maybe let them choose. Okay. Yeah. Okay. Because this could be the way if it shows up later on a problem set, or if it whatever, then do it this way. Okay. All right.